Okay, this is cycle 2, week 5. We have 2 experiments today. We have number 13, expanding, and number 16, in and out. And the supplies that you'll need for this are you're going to have a yard of string in your bag, a spool that looks like this, and a spoon. And this will all be provided for you on the morning of, and it won't be connected like this, but for the sake of the video, I did that beforehand. And you'll also need your science journals and pencils. You'll need a balloon and a Sharpie marker. And those will be, the balloons will be in there, and you'll have to just pull out your Sharpie markers that says so on the back. And if you have a copy of the book Indescribable, I have a couple pages that would go with this lesson if you have time to read them at the end. So the first one that we're going to be doing is expanding, and what we're going to do is we're going to start by reading a few verses from Job that talks about how God is the one who made the world and the universe and everything in it. And so stop for a second and talk about how God is the creator of all things and how he's sovereign over all and he holds it all in place. I think it's just good to put that in perspective before we start. But what we're going to talk about, what we've already learned, we're going to talk about the planet names, we're going to talk about the solar system, the Milky Way galaxy, and the universe, have them tell the things that they know about it. Most children know some tidbit of fact about the solar system. They may want to try to tell you the order or something like that. That's great. Get them excited about it. Let them yell that stuff out. What do we still need to find out? We need to know where our solar system is in the Milky Way galaxy. We need to know where the Milky Way galaxy is in our universe, and just to kind of get perspective on how tiny our little solar system is in the whole entire universe. So we talk about that scientists do research beforehand so that they can have a good experiment and ask the right kinds of questions. So our hypothesis today is if we draw dots on a partially inflated balloon, how will the dots change as we fill the balloon with more air? So that's our question that we're wondering about. So we're going to ask the kids a couple questions, have them raise their hands if they think that the dots on our balloon or the stars are going to be getting closer together or further apart. So for our materials for this, we need a 9-inch balloon. We actually have a little bit larger ones for the student. This is a little bit smaller. And we have a Sharpie marker. And what they're going to do is they're going to get in pairs, and they're going to each take turns doing this. So every child will get to blow on a balloon. They're all going to want to do that. But one student will blow it, and then other student will draw the balloons on. So you'll blow it the size of an apple, about like that. And then the other student will draw our little stars on. And that's going to take a little working together because it tries to move around. But it doesn't have to be perfect. Just draw some stars on. And we might have some kids that actually want to draw stars. But anyway, like that, okay? And then they're going to draw it on, and then they're going to look at the other student, and they're going to continue blowing. Blow it even further, and we're going to talk about what happened to those stars. Did they get closer together? Did they go farther apart? And have them draw the dots on the entire balloon up here and at the back of the balloon as well, the front and the back, because what you're going to notice, and this is in the conclusion, that the ones that were closer to here stayed closer together, and over here where the balloon stretched more, these ones expanded even more. And so scientists believe that's kind of how it is with our universe as well. It's expanding at an even greater rate at some parts of our universe and not getting closer together. So our conclusion's all right there. So that's the first part of the experiment. And you'll read through the results together. I also have a little bit of a visual that you can show the students and just kind of talk through what we see here. So you can show that at the end. And then for the second part, from number 16, for in and out, we're going to be talking about how satellites and planets stay in their orbit. What is it that keeps them in orbit? So we're going to see what forces are at work and how that all works together. So I have a couple verses for you to read to them. We're going to talk through some questions just like we did before. What keeps things in orbit? Why is an orbit? Is it round or is it elliptical? What have we learned about satellites? What about gravity, forces? We've got a bunch of questions here. We're just getting the kids thinking scientifically here. And if you had time, you could have the students draw a picture in their journal of what happened here. Just sketch a little thing really quick. I forgot to say that, sorry. For our next, so for this in and out, number 16, the materials that we need a piece of string, we need a spool and a spoon. And what we're gonna do is we're gonna talk to them about, the tutor is gonna do this part first because it could be a little bit dangerous if we just sent them all off with it. So we're going to tutor model this first. So we have this piece of string. We're going to tie it on the side of a spoon. And I did this 2 times. If you tie it towards the middle, and I'll show you, this gets a little wonky, and I think that someone might get hurt. So it works out even better, and I brought 2 to show you. If you tie the string as close to the edge of the spoon as possible, so that would be just having tried it, that was just a good note. And make sure it's pretty snug because we don't want this flying off and like breaking a window or breaking someone's teeth or anything like that. And we're not gonna get crazy with it. So basically we're just gonna hold it like this in the center and like that. And I'm gonna not hit Julie's lamp here, but we're gonna swing it around like this, and then we're gonna let go of the tape roll. And even though we're not touching the string or the tape, the forces that are acting it are gonna hold it. And so the conclusion is we're going to talk about what are the forces that held this. These are like counterweights to each other. So we have equal forces pushing right. We're going to talk about Newton's law that makes that happen, his first law. And we're going to hypothesize with the kids. What would happen if the spoon had been a huge one, like a huge ladle? And what if this was really a weight that your parents work out with? Would that still work? It needs to be equal force. So we're going to talk about that in the conclusion. It tells you all the sciencey part. But my suggestion after trying it would be to tie it towards the end of the spoon, and you will get these 3 things in your bag. If you have an older class and you think your children are responsible enough and aren't going to kill each other, I would have one kid at a time get off the table and back away from it and let them try it. I think it would be perfectly fine if they tried it, just as long as they're not sitting right next to another kid. So the kids are welcome to try that as well. But because everybody's going to want to get their hands on it, I also purchased a bunch of really cheap yo-yos. So just pull those out, and it tells you how to tie that in and talk about what gravity pulls that yo-yo back up. And these are cheap, light yo-yos, so they're not going to bounce back quite as quickly, so you can talk about the gravitational pull of that. But they've probably all played with a good yo-yo at least once in their life, and the weight that's associated with that and the size. So talk about how size and weight affects gravitational pull as well, and so they can experiment with the yo-yos that are provided as well. So just an extension so they can hold it and touch it. And I believe they can take those home after you're done with their experiment, have them put them in their backpacks so no one gets hit with a yo-yo. And feel free to have them journal and draw pictures in their science journal if time allows. And I have a couple pages listed on the indescribable devotional book that go really well with this if there's time.